We'll proceed in solving tedious calculus problems. Okay, so we are in mode to solve the tedious calculus problem, but rather taking the problem one by one, we are trying to show that how someone should come to know that we have to use calculus. At the end, whenever in real life example, it will not be written that you have to solve through algebra, you have to solve through numerical science, you have to solve through vector, you have to solve through calculus. At the end, the problem will be given and you have to solve. I'm not talking about examination. Examination is different thing and real life is different thing. In real life, if someone need to solve something, then he had choice. He had choice that he want to get it he want to solve it through calculus, algebra, whatever it is. Now, idea is concept is how someone would be sure that he has to use calculus. Anyway, the the rule of thumb rule is that if something is solvable by numerical science, then it should be solved by numerical science. Then, if it can be solved by algebraic science, then it should be solved by algebraic science. If not possible, then only someone should tackle the calculus. Calculus means calculus has two parts. One is integral calculus, that is parallel to or synonym of multiplication, and one is differential calculus, that is synonym to division. In numerical science or algebra, there is division, x squared by x. Okay, if division comes, then it is differentiation. If multiplication comes, then it is integration. Multiplication of two items when one item is dependent upon another. Division of two items when numerator is dependent upon denominator. Okay, if these are the scenario, if it prevails, then we use calculus. How we know one is dependent upon other, then we will see it. What we have seen till now is how we can calculate the length of a how we can calculate length of a curve. If I have a curve, how I can calculate the length of a curve. Okay, so if I have a curve, this is x-axis and this is the curve, then how to calculate length of a curve from where the x-axis I take any point x and this is origin. From origin to any point x on x-axis that will go and touch here. From here, what is the length of the curve? Okay, then we found that how we tackle. Now, if I know this is a curve, then take a straight line. Go with the pseudocode of the algorithm. So, algorithm pseudocode comes when we take anything that is straightforward. So, straightforward. Now we took as this is x-axis, then there is a straight line. If there is a straight line, then what is the length of this line from x equal to 0 to x equal to x? Okay, in that sense, we saw that we have to represent this line in vector form. This point is x comma y, then this vector is xi plus yj, xi plus yj. That is equivalent to x into I plus x, I plus y by xj. Same as I plus y by xj, bracket closed into x. Okay, then what is this? This is the this is the vector notation of the line at till any point x comma y. Anyway, vector notation. What is it? Its magnitude. Magnitude is 1 square plus dy by dx whole square root into x. That is the magnitude. Okay, if that is the magnitude, then that is the length of this line from x equal to 0 to x equal to x. That is that is 1 square plus dy by dx whole square root and then x. Now if we proceed further, then there are two ways to tackle it. We saw one is primitive calculus, one is modern calculus. So primitive calculus says that now this is pseudocode. Pseudocode to calculate the net length, and in pseudocode it is I plus it is 1 plus dy by dx whole square root into x. Now, I'm sorry, 1 plus y by x whole square and then a square root into x. Now, in primitive calculus comes into the picture when it is not a straight line. Calculus comes into the picture when it is not a straight line. It is other than a straight line. Then it is fully algebra, non-linear algebra. In that sense, calculus comes into the picture replacing division by differentiation and replacing multiplication by integration. Okay, consider it is not the case of independent and dependent. Then still integral calculus will work, differential calculus will work. Division is subset of differentiation. Multiplication is subset of integration. Can I solve anything through integration and division? Yes. Anyone can solve anything through integration and division. That is the story. So blindly can someone can write a pseudocode and transform y by x to dy by dx and anything dependent independent to integral into differential form, that integral into dx. Anyone can do like that. Anyway, so y by x transformed into dy by dx. Now it is 1 square plus dy by dx whole square root. Now this full term is again dependent upon x. So into x that is independent becomes dx. This is the net length of the line or curve. Line became curve when y by x becomes dy by dx, and then multiplication becomes into dx instead of x. Then it becomes a curve. Okay, so that is the scenario. And y by dx, we cannot take a numeric value because y by dx is variable for the curve. Means at every, if I take x-axis here, if I take x-axis here, any x-axis y is there, any x y is there. This y by x, every moment it is different. That's why I cannot just calculate the length of any curve by saying 1 square plus y by x whole square root into x, because y by x is not constant. It has to be constant. And then algebra comes. There is a modern way also. Modern way is we chop this curve into many sections. So consider this is x-axis and this is at any point x. It is point in x comma y. I want this full length. Let's chop it into n part. Now every part it will behave as a straight line if that n tends to infinity. If I chop it into 10,000 parts, then every part it will not be a curve, it will behave like a straight line. If it is a straight line, then I have the equation for the straight line to calculate the length. That is 1 square plus y by x whole square root into x. Now here, if I chop it into many parts, then one part has a width called delta x. Accordingly, height is delta y. If it is ith part, I chop it into n part and this is ith part, then ith part length, because if I add all the length, then I get the length of this line. The ith part length is 1 square plus delta y by delta x ith part whole square root into delta x of the ith part. Now we can sum it, and it is summation mark I equal to 1 to n and 1 square plus delta y by delta x whole square for the ith part square root into delta x ith part. Now, if I take it is exact representation of integration. Exact representation of integration, where we try to calculate something making into a chopped part. In that sense, it becomes 1 plus dy by dx whole square root into dx. Either you take primitive calculus or modern calculus. I believe primitive calculus is more handy. Anyway, where we started that if I want to calculate the length of this curve, then I take a pseudocode. Pseudocode in the sense that I won't take this as a curve, I take this as a straight line, and then I take any point x comma y and I get the vector of it and calculate the magnitude. We get the length. Vector is xi plus yj. then magnitude is x square plus y square square root, or the vector xi plus yj can be represented as x I plus y by xj, or 1 plus y by xj, I'm sorry, I plus y by xj bracket close into x. Okay, that is the scenario. If I go with primitive calculus, it becomes I plus dy by dxj. Haha. I plus dy by dxj into dx. Okay, this part I have to calculate I have to calculate whatever it is. I have to calculate magnitude of it. Then only I'll get the net length of a vector. Then whatever it is, I'm sorry. Now the net vector I am seeing is I plus y by xj into x. If I see the primitive calculus, it becomes I plus dy by dxj. This is the one vector form into x or dx. This vector form can be written as dp by dx, where position vector. If I take any point here as p, if I take any point here as p, then this position vector is xi plus yj. dp by dx is I plus dy by dxj. That is dp by dx. If position vector is xi plus yj, dp by dx is I plus dy by dxj. It is exactly same. Now we have the new representation of vector in primitive calculus is dp by dx, dp by dx into dx. Okay, where I have to calculate dp by dx, dp by dx, the net magnitude into dx, that will give me the net length. No. Actual net length is I plus dy by dxj. For this, I have to calculate the net magnitude into dx. Same thing I am saying. dp by dx is same as I plus dy by dxj. Calculate the magnitude of dp by dx, and then whatever comes in algebraic form, integrate with dx, you get the net length from 0 to x, wherever net length is seeked. Anyway, so this is the kind of to find the length. What we did is whatever we had, the actual vector representation was xi plus yj. We could have calculated the length as x square plus y square square root. But this will not give variable as far as curve length is concerned. To get the curve length, I have to bring it into differentiation and integration. Then I brought up into a form called I plus y by xj into x. Now with the primitive calculus, it becomes I plus dy by dxj into dx. Now it came as calculus. Calculus in the sense that now y is the dy by dx. Numerator is dependent upon denominator. So it will turn into dy by dx. And this full term 1 square plus dy by dx whole square root, this full term, that is a function of x is dependent upon another x that is on right hand side. So the another x will become dx and it become an integral calculus. Now we can have a smooth calculation for any variable curve. Okay, or cut the curve into many sections and make sure that one section is a straight line. Okay, to get the length of this curve, cut the curve into many sections and get the length of each section and add it. Each section, if each section has y component and x component, y component is delta y, x component is delta x. If delta x tends to 0, this component will behave like a straight line. If it is a straight line, then we know that how to calculate the length. That is I plus y by xj, magnitude of this into x, that is 1 square plus y by x whole square root into x. Now here x is delta x and y is delta y for the ith component. Then 1 square plus delta y by delta x whole square root into delta x. Now we have to sum it I equal to 1 to I equal to n. All we have to sum all the section. Then it will become 1 plus dy by dx whole square root into dx. Okay, someone can try y equal to y, consider it is y equal to x square. Then 1 plus dy by dx is 2x, 1 plus 4x square root dx. Actually, every time I'm thinking that I'll calculate it, but I could not get time. But this integration is not straightforward. 1 plus 4x square, anyone knows it, then he can calculate the integration and the limit is 0 to x or whatever comes to mind. Anyway, so we will begin now how to calculate how to calculate surface area of a curved section. Okay, idea is not to calculate the surface area of a curved section. The idea is to calculate the idea is to introduce calculus in case study. If someone is giving a problem, how to proceed in case study. So this is a round surface. I'm not saying it is a sphere. This is a round surface for which this is a 3D. If it is a 3D, then I take xy plane, I cut it at the center, and this is centered at the origin. Blue color is the origin. This is centered at the origin. Half of it is top hemisphere, half of it is bottom hemisphere. In that case, what is the surface area of this? For top hemisphere or bottom hemisphere, the algebraic equation is x square plus y square plus z square equal to a square, that is the radius. X square plus y square plus z square equal to a square. Then z equal to square root of a square minus x square minus y square. That is the formula. This is how it is. That is the formula, and this is how it is. Okay, thank you very much. Then calculate the surface area of this. Now we will go with the pseudocode. Pseudocode in the sense we will try to calculate surface area of a flat surface first, and then get. This is the rule of thumb. Whenever complex problem comes, then go with the simplest case and try to get the algebraic equation and convert it into multiplication and division, and change the multiplication to integral calculus, change the division to differential calculus, provided in multiplication one is dependent and one side is independent in the multiplication. Two operand for the multiplication operator. Left side, probably left side is dependent and right side is independent. In division, numerator is dependent upon denominator. Then it will transform into calculus. So first someone should try to get for the simplest case area. Now consider this is a simplest case. Simplest case means this is x-axis, this is y-axis. It is simplest case. This is a rectangle, and this is point P. This is point P, and this is origin. This is origin. This is origin, and this is point P. If that is the case, calculate the area of this. What is this P? P is xi plus yj. If this is x comma y, this is xy plane. From my side, this is x-axis and this is y-axis. This is this. I'm sorry. This is origin and it is at my side. This is y-axis and this is x-axis. This is point P. Okay, from origin to point P, whatever the area is coming, can someone calculate this area? This is a flat rectangular region. If that is the case, then how to calculate area of this rectangle? That is under question mark. This is x-axis. This is y-axis. If I have two vectors, this full area comes under x-axis and y-axis. If I have a vector, what is this? Consider this point is x and this point is y. Then this point is x comma y. This point is x comma y. In that sense, this is x-axis and this is y-axis. If that is the scenario, then what is this vector? This is xi. What is this vector? This is yj. If I have a region that is confined between any two vectors, and if I take cross product of it, then it gives the area. This is inherent nature of vector. So if I have a vector that is xi along x-axis and I have a vector along y-axis that is yj, then xi cross yj will give me the area. Indeed, it is x into y, and that is the area of a rectangle. x into y is the area of the rectangle. I cross j is k vector. Means I have the area of this is x into y k vector. Now to calculate the net area, I have to calculate magnitude of it. That will come at x into y. Okay, why you did this? But just you could have multiplied x into y to get the area of a rectangle, that is x into y. Wait, wait, wait. We will do more in it. Anyway, if this is the surface, now this is y-axis. Keep y-axis constant and lift it. X-axis is now, from my side, this is x-axis. X-axis went up. If x-axis went up, then what would be the area of this shape? Same. Area of this shape will be same. Area vector may be different. No, it is not k, it is something else. Here, if it is xy plane, the area vector is k. But here, area vector is something else. Now, keeping the x-axis constant, I can lift the y-axis. If that is the case, then what is area of this? Same, x into y. But how I can calculate it? The way you are saying same, 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 same. Okay, now let I move it, keeping y-axis constant, I move like this. What is the area? Area is this vector, that is along x-axis. Now x-axis has lifted up. This is this vector cross product with yj. This is no more xi. This is xi along x-axis. This is something else. Now consider this point. This point is x comma y comma z. This may not be x comma y. If this is x comma y, if I rotate it, it will be less than x. But right now consider this point, the end. This is origin. From my side, this is origin. This point is x comma y comma z. If that is the case, then this point from this side, where I am at this side, this point, this side, this is xz plane. This is yz plane. If this is xz plane, then this point from my side, this point is x comma z. Okay, this okay. In that sense, this is the point. This is xz plane. If I take xz plane here also, this point is x comma y comma z because it is distance y from here. But if I take along the x-axis above it, exactly exact plane that is above the x-axis, then this point will be x comma z. Now keeping the x-axis, this side as constant and lift the y-axis. If that is the case, now consider this point is x comma y comma z. Then this point that is above the x-axis, this point is x comma z. Whereas this point, this is y-axis, this is yz plane, and in yz plane x is 0. YZ plane when it is cutting the y-axis. XZ plane when it is cutting the x-axis, y is 0. Here x is 0. This point is y comma z. Now watch minutely what we are doing. These explanations are not available in any of the book. So watch it carefully. Now what is area of this? Area of this is this side vector cross product with this side vector, and it will come at xy only. But anyway, area of this is this side vector. What is this side vector? This side vector, if you see, then this point is x comma z. Okay, x comma z means if I go down straight on x axis, it will cut at x and height is z. Similarly, here if I go down, then it will cut y axis at y and height is z. If that is the case, then this vector, what is this vector? This vector is xi plus zk. Whatever this vector, this is yj plus zk. What is the area? xi plus zk. xi plus zk. Cross product with yj plus zk. Let's do the cross product. I never tried it. Xi plus yj. It becomes x into y. It becomes x into y. X into y. K. X into y. K. Then cross I cross k. I cross j. I cross k. Then it becomes x z I k. X xz minus j. Xz minus j. Okay, and now second side we'll try y, second is z, z, z into x, okay, that is z into I, it becomes j, zj, and then k cross product will not work. Up. I'm sorry. So one is I and j, then I and k, okay, then k and I. So it will have I and k and I will be j, I and j, k and I will be j, I and k will be again j. So one is x into z and one will be y into z. Okay, whatever it is, just leave it for right, right now. Anyway, so the net area, what we see now, okay, one vector is xi plus y, xi plus zk. Another vector is another, now I tilt it like this. Now, if I take xz plane, then this is a straight line. That is a vector. Earlier, the vector was xi plus y, xi cross yj. That was the area. Now, keeping the y-axis constant, if I tilt like then this vector this vector is this point, and this point minus, this is origin, and this point is x comma j. In that sense, it is xi plus zk, xi plus zk. Okay, and this point, if now keeping this side constant, if I lift like this, then this point is y comma z. This vector is yj plus zk. Now net area is xi plus zk, xi plus zk, cross product with yi plus zk. This z height may not be same, whatever it is, but this is how it is. Okay, if this is the case, then what is the first one? Xi plus zk. It can be represented as x and in braces I plus z by xk. Cross product, then y I can take out. Then it becomes j plus z by yk. Okay, that is the calculation of the net area. Okay, now x and y I can keep right side, that is x into y. Now because cross product comes with the a vector, not with the algebra. Now we have I plus z by x, I plus z by x k, cross product with j by plus z by y k. Okay, now if I see z is dependent upon x and z is dependent upon y, then it will transform at dz by dx and there dz by dy. Now we have two vectors I plus dz by dxk, cross product j plus dz by dy k. Okay, now this is the net area into x into y. Whatever I plus dz by dx k, cross product j plus dz, let's calculate it where to run away. I plus dz by dx, I plus dz by dx k, cross product with j plus dz by dy by k. Now this will be perfect because we have taken differentiation. Now it will come as I cross j, that is k. Then I cross k, I cross k will be minus j, and then j cross, here k cross I is minus j, and then k cross k is nothing. Altogether it comes as minus dz by dxi minus dz by dyj plus k. Now, whatever cross product comes, we have to calculate the magnitude of it. This is a vector. If I calculate magnitude of whole thing, the idea what is that whatever comes, if you remember, if it was the xy plane, then this was xi plus yj. If I take cross product, it becomes xy into k. Then I have to calculate the magnitude because cross product will lead to another vector, and that vector magnitude will be the area of the surface. Similarly, I have one side is x into I plus dz by dx k, cross product with y into j plus dz by dy k. If I take cross product, it will come as a vector. Calculate the magnitude, it will give the net area. The net area of a vector, that is minus dz by dxi minus dz by dyj plus k into x into y. Calculate the net magnitude of it, it will give the net area. That is algebra, it will remain there only. Now it becomes dz by dx whole square plus dz by dy whole square plus 1 square root. This is the net area between these two vectors, this vector and this vector. This is the net area, dx dy, dx dy, I'm sorry, x into y. Now, why we converted z by x as dz by dx? Because z, that is numerator, if I tilt it like this, then the height what we see is dependent upon the x. At different x, we have different height. Okay, so height is dependent upon x-axis, z by x. So denominator is independent and numerator is dependent. So z by x become dz by dx. Similarly, z by y became dz by dy. Anyway, net came dz by dx whole square plus dz by dy whole square plus 1 square root. Now this whole will be an algebraic equation in term of x and y. Here we have two independent components. One is x-axis and one is y-axis. Two independent components. If that is the case, if there are two independent components, then we whatever we have this formula dz by dx whole square plus dz by dy whole square plus 1 square root, it will come in term of x and y. This dependent component is dependent upon x into y, that is independent. X into y is independent. If multiplication of dependent and independent is there, I can say d of x into y. It will transform into integral calculus. Now we have dz by dx whole square plus dz by dy whole square plus 1 square root into d of xy. D of xy, x and y, they are orthogonal to each other. So d of xy can be written as dx dy. This is the net area of a flat surface. Area of a flat surface is dz by dx whole square plus dz by dy whole square plus 1 square root dx dy. Hope. Okay, so probably it is, we are half the way, and actually the area of the flat surface is not dz by dx, it is y by z by x and z by y. But we are transforming it into any surface. Flat surface, the flat surface actual equation is z by x whole square plus z by y whole square plus 1 square root into x into y. This should give the result of the flat surface. But now when we are generalizing it for any surface, then it will slowly transform into division, will transform into differentiation, and multiplication will transform into multiplication. This is what we have seen in the two dimension y and x. We calculated the length of a line, straight line, and that came as y by x into x. And then if I wanted to generalize for any line, then y by x transform into dy by dx, because y by x is not unique in curve line. Every moment y by x is different in curve line. If it is a straight line, then y by x is a numeric number, it is constant. But y by x for a curve line, y equal to x square, every moment y by x is different. When x equal to 4, y by x is 4. When x equal to 2, y by x is 2. It is different at every moment. In that sense, if I want to generalize the length of a curve, that is 1 plus y by x whole square root into x, then y by x will transform into dy by dx, and x at the end will be transformed to dx. Similarly, the net surface area is 1 plus z by x I plus z by x k cross product j plus z by y k x into y. This is the net cross product. Someone settle it down, it becomes minus z by x I minus z by y j plus k. Okay, then x into y. Now magnitude of is the net surface area, that is z by x whole square plus z by y whole square plus 1 square root x into y. This is for flat surface. But if I want to generalize it for any kind of surface, then y by x will not be a constant. If y by x is a numeric number, then straightforward anyone can calculate. Straightforward. Anyone can calculate. If it is not a numeric number, then y by x will transform into dy by dx. I'm sorry, z by x will be transformed to dz by dx because it is variable now. Z by y will be transformed into dz by dy, dz by dx whole square plus dz by dy whole square plus 1 square root and then into x into y. Now this one term is a square root and one term is x into y. They are multiplication of each other. And right hand side xy is independent and this will come into function of x and y. Then integral calculus dot d of xy. So dz by dx whole square plus dz by dy whole square plus 1 square root into dx dy is the net surface area for any surface. Okay, limit is x is x1 to x2, y is y1 to y2. Okay, this is one way we talked about. There can be many ways to calculate it, but at the end, result should come at the same place. So we will proceed. Don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.